We're on board.
We're going.
Okay, great. Well, without much further ado, thank you for those of you who are tuning in, this very late in the evening on the East Coast or early in the morning internationally. Wanted to thank everybody today. I know the delegates have had a pretty long day, and many of you have come from far and wide. And we are also the company that's sitting between you and the bar. So that's put a pretty high bar out there. But hopefully we'll do what we can to really educate you. So there's going to be two presenters today from Xangati, and I am one of them. I'm David Messina. I'm the Vice President of Product Management for the company. And what we really wanted to do today is Field Day, as we saw, was a really great opportunity for Xangati to get exposure with an audience of delegates like yourself. I mean, in a world that everybody is entirely virtual. I mean, it's very difficult to get this many sort of deep thinkers in one place at one time. So what we wanted to do in that regard, just in terms of an agenda, if my computer wants to work, is give you a little bit of an intro. I know there are a couple folks in this audience that I've worked with and engaged with in the past, but many of you are not familiar with Xangati, so we'd like to get into that, and certainly many on the internet are not. Do a demonstration of our product. And the reason we want to do that is we offer a performance management solution. And one of the things about the management market is that we found that there are many products out there, but ultimately our product often speaks for itself, and we want to walk you through the UI. But from there, I'm going to basically pass along to Jagan, who is the CTO and founder of the company. And he is going to get into an architectural deep dive of some of the underpinnings of the solution so you can understand why it's different. And then we're going to shut the camera off for the audience out there and kind of give you guys a closed-door session. Again, we've only got an hour, but we want to give you a highlight of some things that we're bringing to market in March, and then also even talk a little bit about roadmap beyond that. So that's going to be our agenda. Just a little bit about Xangati. As I said earlier, we talk about ourselves being a performance management company, specifically infrastructure performance. What I mean by that is that in a world where virtualization and cloud is really taking a foothold into enterprises and service providers, that the infrastructure, there's a lot of dynamic shifts that occur. And when I mean infrastructure, I mean anything from the servers to the network, all the way out to end user devices, physical and virtual. And that's one of the things that we do uniquely is look at things from a performance management perspective, cross-silo. Again, the reason that some of you are not particularly familiar with Xangati is we really are generally new to the virtualization market. Our first release in this space as a virtual appliance was March of last year, and thanks to our engineering team, we're now on our third release that we'll be announcing in the March timeframe. And for audiences out there, we're focused both on server virtualization as well as virtual desktop infrastructure. And our focus really here is ultimately working on dashboards that enable the specific users, whether it be the VI admin, the VDI admin, perhaps a storage admin in the future, to have a context that is very specific to what they need to do to get their job to understand performance from their vantage point. So one of the things that we've learned over the past year, types of customers that end up resonating with the Xangati solution and have become our customers is we see this around what we call the virtualization blame game. That virtualization in many ways is the new kid on the block, maybe not so new at this point, but it's generally the newest thing in the IT infrastructure. And it's kind of last in, first to blame syndrome. We have a lot of customers who are about 30–40% virtualized that spend a good chunk of their day, anywhere from 5 to 25% of their time, dealing with other departments, trying to prove that when things are slow, it's not the virtual infrastructure that's responsible. Many of you, we see this with customers, all the lights are green, but it doesn't look like virtualization is a problem, but everybody else is telling us that it is. So, our goal today, again, if I think about it, when I originally talked to Stephen about the opportunity to speak to this audience, one of the reasons that we're really excited is that when we go out into the market, there are literally dozens upon dozens of companies that do management in the virtualization space. And what we wanted to use this time to do is really kind of deconstruct and parse through architecturally what we see are some of the key things to look at as you're trying to manage a virtual infrastructure. And there are many other categories of product in this space. There are great products that do capacity planning, capacity management, configuration and change management. The kinds of customers that we're working with are generally focused on performance issues. When they've got performance problems, generally need to look for a performance management solution. So if somebody has that as a first order problem, generally that's where the interest is. What we see a lot is there are many companies out there that are focused on leveraging the VMware APIs, APIs from the other hypervisors as well. But that's a starting point in this journey of how do you manage performance. Seeing across silos is very critical. I mean, just to give you some examples, we have a customer where they're doing a virtual desktop implementation where, if you just look at the virtual desktop infrastructure, there's no problems within that construct. But what we're finding is that looking into storage, we can actually see that there are storage backups that have actually run longer, running into the middle of the day, that actually affect the performance, the end user experience of the end user desktop. So the point is that oftentimes when you're trying to triage and troubleshoot, that you want to be able to peer across silos, and we'll talk about that in more detail. And one of the things that is very unique, and we'll get into the UI in a second, is that virtualization is about a dynamic infrastructure. Things self-heal, they move around. Being able to see dynamic shifts literally as they happen is one of the kind of unique points of what Xangati does. And when Jagan gets into the architecture, this is really in the architectural bowels of the system. So one more slide, and then I'm going to cool off the PowerPoint because this is an audience that I know likes digging in deep. But we use this slide, we call it the rainbow slide, but we use this slide to explain a little bit about some of the things that we do differently. So for a virtualization admin, often the center of the universe is the virtual machine. One of the things that's unique about Xangati, and we'll talk more about the deployment in the future, but the reality is that as a virtualization admin, I'd like to know a lot more about what that virtual machine does, right? So not just what its CPU, memory, disk is, kind of how much load it has on the network, but what is it doing? Which end user device is it interacting with? Maybe out on the front end. What is it doing on the back end? What kind of applications and protocols are driving that desktop? And because we have a unique vantage point of one of the data feeds that we get is from the virtual switching infrastructure, we can give a lot more context around this virtual machine. And when we think about our roadmap, and we'll talk about this a little bit, our goal is to really add a lot of depth into peering into all these silos. So although today, the virtual machine might be the context in which is in the center, but perhaps, the protocol like ICA or PC or IP could be in the center, or the desktop, or the client, or storage, what have you. So we use this. I know it's a marketing slide, but it helps us educate customers in some ways how our solution is different. So as an example, when the CPU is spiking on a virtual machine, what was that virtual machine doing? What was it interacting with? What kind of applications on the network were there? So this is a slide that Jagan will talk to. So let me just switch over to our system. And I know it's a little bit blurry, but can folks see in the back of the room? And I don't know how it's doing on the camera, but this is the Xangati UI. And our UI, as I said earlier, one of the things that I highlighted is there's something about our system that is different than other management systems in the sense that it's live and continuous. So any view that I have literally has a DVR scroll bar attached to it, and we'll talk about the use cases around that. But there's a lot of resonance with this. And I think there are certainly international folks here, so we call it DVR. I think others call it PVR, personal video recorder, just to make sure we baseline. What we're seeing right now is kind of a top-level dashboard. And as we get into the details here, what our customers like is they can really drill down kind of swoop into a specific element. So what you're seeing up here is a combination of statistics that we would take from vCenter, as well as from the things like the virtual switches or physical switches in the infrastructure. So I can immediately sort of bubble up who are the top VMs in terms of their usage of CPU, memory. I can look at storage. I can also look at the top applications that are running in my infrastructure. So right now, if I choose to look at Citrix and I double-click on that, I've switched from a top-level dashboard of what's going on, top talkers, top applications, top users of resources, and I've now immediately gotten to, that's the application up there, Citrix ICA, and then I can see who the top generators of that application are. I can see which hosts that application is running in. I can also see exactly how many users on my infrastructure are using that application. And then I can go one level deeper. So I can look at this specific desktop. Now I can see, again, this idea of VM to anything. I can see that this desktop is interacting with this client, with this application. And by the way, I can also see its interaction on the back end with any back end servers as well. And if I do what we call a right click, I can zoom in. Now I know it's going to be somewhat hard to see, but I am zooming in on the conversation effectively between this desktop and its client. And I'm starting to see how much load. Let's get that. How much load it has on the network, about kind of megabit per second. You can see what applications are being conversed, if you will, between these two endpoints. Now, this ability, again, to navigate in real time, as you can imagine, is very helpful when you're looking at a troubleshooting scenario, because again, I can go from anywhere from an application to a host down to a desktop. I can look at anything from the host to things like port groups on virtual switches. And like I said earlier, everything has this DVR record button. So I'm looking at a specific conversation between these two desktops. Now that I've got the record button pressed, I have the recording there. And then when I go to the recordings tab, well, let me focus on it over here. I'll have a set of recordings that will pop up that effectively I can play back. Now, over time, what's happened with the evolution of this recording functionality, because it's a very sticky feature, is that we went from sort of a model where just the admin could drive the recording to one where vCenter, as an example, can drive recording. So if there's an alert for a host, if there's an alert for a VM, that can actually send a trap to the Xangati system, which will trigger a DVR recording.
So then, does the DVR have a buffer? Because when the event happens, you might want to know like a minute before. What was going on before that? Is there a way that there's like a buffer that's included?
Yes, actually, the system has the ability to effectively have you define the buffer. So, if you notice, actually in the lower right corner, it will say roughly a minute delay, and that's largely for buffering that information. You can actually adjust that as well. And again, that's, example is admin driven, vCenter driven. Give you one of my favorite use cases of the vCenter driven alert. One of our customers is Guess, and they had a spiking host. The CPU had run amok. They looked at our recording, and what they found out was that the #1 driver of the CPU was a video server. And it was, instead of 3 users using it, there were 50. And it was at an incredibly high encode rate because they had just done an HD all-hands video. And didn't really give it much thought that the server was running on a shared infrastructure. It didn't really matter if they had a dedicated video server, but when it's shared like that, something not well thought out can have an impact on everybody else. But it's an example of where you can get recordings. We also have, and we'll talk about this more in the VDI case, we have a case where end users can trigger recordings when they have a problem. And we'll come back to that a little bit. And also the system itself can generate recordings based upon some of its analytics. So I've covered a lot of ground. I've had some coffee. I want to see if there are any questions I actually probably need those, or maybe the bacon to slow me down.
So, what type of stats can you consume outside of vCenter, and what sources?
Yeah, so, well, Jagan will get a little bit more into this in terms of feeds, but, quick answers. We can get information from the virtual switches about every conversation.
That's VMware in general, but outside of VMware?
Yeah, outside of VMware, one of the things that we can do is look at response time within the virtual infrastructure and from the virtual infrastructure out to the physical infrastructure. So
what would that be?
What's that?
What would that be then? Like,
well, network latency.
Web server response time or database?
No, more at a network latency level. To give you a use case, big in VDI is, as an example, what's the response time between a remote subnet that users over the WAN are getting VDI? Is there some kind of network latency issue? So that's something that we would gather. We have a system that does that. In addition, we are also getting information from the physical network. So the switches and routers on the physical network can.
That's what I'm getting at. Yeah.
Yeah.
So you're grabbing them from switches. You're grabbing them from.
Yeah, we're also getting.
The list of sources that you can grab data.
Okay, well, I'll let Jagan talk a little bit more about those, but we're also getting information from various directories as well. So one of the things that is important for us is looking at an identity, right? So instead of just looking at a raw IP address, I'm getting information about the IP address, but then I'm mapping it to like a DNS name or a vCenter name, what have you. And go ahead.
Is it all agent-driven?
No, actually, it is based upon virtual appliance architecture. So one of my slides, which I didn't really dig too much into, we don't have, what we have is a kind of general dashboard virtual appliance, which is kind of sit anywhere in the data center. And then we have a virtual machine that also sits on the host that effectively is co-resident with the virtual switch and is summarizing all that information.
So one virtual machine
per host.
Per host.
Yeah, not per guest, one per host. So what I'd like to do, I can come back to doing a more detailed demo, and in fact, one of the things I'm going to be doing as well is getting into some new UI feature sets that we have when we turn off the camera. But what I'd like to do is get Jagan up here and give you a sense of some of the architectural underpinnings here that, it's not, I think one of the challenges with the user interface is that, a lot of it, hides the complexity of what actually is being done on the back end. And so that's what I'd like Jagan to talk about. Okay, I messed it up.
I'm going to lift this up.
Okay, sounds good. Okay.
So I don't have any slides, partly because I think I want the discussion to be driven by any questions you have or my perception that you have certain questions just by looking at you. So feel free to keep it interactive. So, I think of what David did as sort of a snorkeling exercise, and what I hope to do is a bit of a scuba diving exercise into really the underpinnings of the system and what drives the user interface. So the user interface is really at the top level, and that's basically what you saw. But there's a lot of stuff that's going on underneath, and before we start on what's going on underneath, I think the first important thing that we sort of make an assumption about is that, first of all, we're not going to be deploying any kind of agents on any of the infrastructure we're monitoring, right? So basically, we have this view that we have to be passive. At the same time, we have to be extensible in the sense that we have to be able to take feeds from a variety of what were traditional silos. So we have to take feeds from network, feeds from storage, feeds from servers. And these feeds, of course, are not all push feeds. Some are pull, some have to be nudged, some come in huge volumes, some come in a trickle. So part of the challenge we have is, and this fishbowl really shows this, is that you have a diversity of different kinds of objects that are generating data. And the collection engine, which is really the first part of our appliance, associated with these objects in really real time. So in effect, the traditional approach to management is to take data, shove it through a database, and then generate reports, right? So part of the challenge they have is to generate meaningful reports, looking back retrospectively at maybe 1 minute, 5 minutes, 1 day, 2 days. Our approach is quite different. We have a memory-based processing of data, which means that yes, this data eventually goes to the database, but that's not where it makes the entry into the system. It's actually crunched in real time. Memory has to be managed because the amount of data that we're getting is so voluminous that if we don't manage the memory, we'll just sort of run out of space and run out of efficiency. So the amount of time literally that we have for each interaction that, for example, point A talks to point B, or a VM has a certain CPU count or memory usage on a particular server. All this information we have literally approximately between 1 and 10 microseconds to process that information. Because the scale with which we have to grow is to 1 million objects. So if you're going to grow to 1 million objects and you're going to render information on a per second basis, you literally have to go to a single microsecond cycle time to crunch that information. So in that cycle time, what you have to do is you have to get the information. You have to do something called mapping. So a lot of the information that you end up getting is very raw information. It's ephemeral information. So it might be IP address, it might be some kind of storage ID, it might be a reference to a VM. You have to be able to map it to invariants that you can use to refer to that object. So that exercise has to be done within that microsecond. You have to be able to support all the visualization that goes on that David showed you. When somebody clicks on something and you want to see it, that activity has to be supported by us. The visualization has to happen within a microsecond. You have to actually do analysis of the data, which I'll get to, which is much more longer term analysis, but you have to set that up, and that has to occur within that cycle time. And then you have to take all this data and put it into the database so that you can do reporting. And that has to happen within a microsecond. So basically the system is real time in the sense that you have to manage the throughput you're getting on a constant basis, and you cannot really stop and think about what to do with this data. You really have to keep going on a second by second basis and a microsecond by microsecond basis for each interaction. So the collation engine is very unique in the management space. It is completely based in memory. There is many techniques we use which manages the growth of this memory, because the representations we use tend to grow fairly dramatically, because what we are focused on, unlike a lot of other tools, is we are focused on interactions. We're focused on interactions between a VM and its ESX, a VM and another VM, a VM and storage, and VM and maybe a client. It's a desktop, a client, a physical client somewhere. So the focus on interaction means that you really have, if you have n objects, you really have n square number of potential interactions. So the interactions actually amplifies the rate at which we have to deal with things. So what I want to leave you with in terms of the collation part is you have to be really efficient to do it, and it's not something where you can do it offline, that is, you store it in a database and crunch the data. I mean, you can do it, but it's not going to be very useful for performance management in a live and dynamic environment. What I've described is a very sort of hyper-hurried activity that we do. We also have a perspective which relates to our profiling and analytics, where we are looking at each and every object that we discover, whether it's a VM, whether it's a host, whether it's a network interface, whether it's a port group, whether it's a client. We are looking at the behavior of each of these objects, and we look at these behaviors in two different ways. There are what are known as consumptive metrics. Consumptive metrics meaning things you can measure, like how much CPU, how much memory, how much network bandwidth, and stuff like that. That is very common in a lot of management tools. But we also look at something else which I think is quite unique to us, which is what we call interactional metrics. Interactional metrics are which other VMs does a VM typically talk to, which storage elements does a VM interact with, what is the affinity of the VM to particular ESXs. So we look at this for every object, right? So we have a sense, if you like, from any perspective, we have a sense of the interactional patterns. And this is not only shown in a visual manner, and a lot of the UI shows these interactions, and you can see it, but it also captures it in a profile so that you understand its inert behavior, its more consumptive behavior, and its social behavior in a way so that when there is a problem, the manifestation of the problem could be that it's, I mean, typically it's too much CPU, too much memory, disk latency is slow, and or it's engaged in some network activity which is unusual. But what you also want to see is which other elements is it interacting with specifically that may be the important thing that explains the consumptive anomaly. So a lot of times what we find is CPU spike is really related to a certain interaction between two VMs. And to be able to see that and capture that and understand that is really important. So the profiling and analytics, it really drives our ability to detect unusual behavior and report them as alerts. And when alerts come, and David mentioned this, they are automatically recorded. So you have a recording of exactly what is going on when this behavior occurred. So even if you're not there, you go and you are able to view it as a DVR recording, and that helps you understand the nature of the issue. I think this is all under the hood stuff. So let me just stop here, and if I've gone too fast or not gone deep enough, or maybe gone too deep, whatever the case may be, let me know, and I'll take your questions.
Good question.
Yeah.
Maybe you can talk about the database that you use.
Yeah.
Is it Hadoop?
Sorry?
Are you using Hadoop for your database?
No.
Can you talk about what you're using?
It's a commodity database that we use. It's
relational or?
It's relational.
Okay.
Okay. But our emphasis is not on the database. So the important thing that you have to understand is you can't do this with your vanilla database. You have to do it in memory. So all of our crunching that we do is in memory. So we digest all the information in memory, which means by the time you go to the database, it is really to store information for retrospective analysis, not for real-time analysis.
So all queries have memory. In memory.
All crunching of data, all management of interactions, everything, tree structures which reflect the different interactions, everything that we do is done in memory.
And this is done per ESX host.
It is, so we have an appliance which manages multiple ESX hosts. So information about all these ESX and the VMs, the constituent VMs, and any of the physical devices that interact with this. Because typically, you don't have a pure virtual environment. You have a small or a much larger physical environment. And so all that information is managed by this. So the number of objects you typically deal with varies from maybe very small systems, 1,000 objects, to 10,000 objects, to 100,000 objects. And part of our challenge, our technical challenge, is to be able to scale with the growth that we typically end up seeing. Because virtual entities grow, like there's no tomorrow. You don't need to buy anything, you just create them.
So what happens with physical resources like your network switches? Do you manage those?
We certainly have information about network interfaces, network switches, even physical clients. So certainly anything that we have access to in terms of information through NetFlow or other means, we will certainly render that and visualize it.
So when you talk about VMs, does it correlate to storage, and does it correlate to, for example, on a certain VM on a certain drive, if the utilization is running high or the IOPS are running high, it visualizes all the way into that detail?
So at this stage, with this release, you won't see this, but the idea is that from any data store, you can see all the interaction to all the VMs. From any VMs, any of the VMs, you can see all the interactions to any of the data stores. So to the extent that the granularity is a data information about how many IOPS, what is the storage read-write rate, what is the latency.
Those stats come from Virtual Center, right?
vCenter?
Yeah.
No,
the stats of the storage.
Stats and storage, right now we rely, I mean, we're agnostic about where we get it from, but right now the most ubiquitous way for us to get storage information is from vCenter. Okay, so certainly with 4.1, richer and more advanced, and certainly we are constantly, I mean, one of the things being agnostic doesn't mean you can sort of just shut your eyes and say that's it. You have to be really open to supporting different sources in a very efficient way. So one of the interests in the VDI world is there are folks who are interested in giving insight into the network interactions of the desktop using whatever the special protocols are with the client. And certainly that could be a data source that we can consume. And so when you're looking at that particular desktop, you'll actually see how that stream scraping protocol is performing in terms where you can actually understand what the issues are when somebody's having lethargic behavior in a VDI implementation.
On the collation engine, I'll ask another question, but are you using anything like a off-the-shelf rules engine, or is it completely custom?
It's completely custom.
So it's not like a rules backend or anything?
No, this is it's custom because I think when we looked at it, it was fundamentally a problem that I don't think others had dealt with, and so we basically had to come up with our own code base and algorithms and techniques and encode them in code. So it's a subject of a couple of patents that we are processing.
You're familiar with rules though?
I'm familiar with
rules engines in general and the math behind it. So you're probably using something similar if you're creating like derived.
Yeah, it's not. I mean, our approach is not. I wouldn't characterize it as rule-based. Our approach is more. It's more, I think, anomaly-based. So it's not. It's basically self-learning behavior, right? So we are not rules-based systems tend to be kind of rule of thumb, certain ways of thinking of behavior which applies to a lot of people. We learn the behavior of each and every object over time. And one of the things we can do in our profiling is we can understand whether behavior is really erratic, in which case you want to be really careful about alerting, or the behavior is quite periodic, which means you actually know what the behavior is going to be at any particular time. So a backup application will have very regular behavior, orchestrated properly in IT. And if you see that, if you see that periodicity in somehow being violated, you can pick that up. And so we range from periodic to aperiodic, from very predictable to very unpredictable, and we take that into account when we do the alerting, so that it's not I have a threshold, it's gone over it, I'll do an alert. That doesn't really work because then people say, well, why are you doing that? So we really have to understand the certainty we have in terms of how predictable it is. Yeah.
So I'm interested in how this scales because as you go from 10,000 objects to 1 million, the relationships or the potential relationships grow geometrically. So just a few words about how you scale, because I could see people getting very dependent on this, and then if it reaches a point where it doesn't scale any further, they're like, oh my God, flying blind all of a sudden.
No, absolutely, it's a very good question. And really the challenge in scaling in any system, and certainly this is no exception, is how much can you squeeze the basic single node algorithms, the single appliance algorithms. How much can you squeeze out of it, and when do you have to go multi-appliance, right? So our belief is that to the tune of close to 1 million objects, we can do it in a single appliance. When we cross 1 million objects, we have a design. We haven't seen an actual requirement which is basically multiple appliances which manage different areas of the infrastructure but interact with each other so that you have a user interface not your, general load balancing approach. Our algorithms have to be spliced in particular ways for this to be done.
Million objects is what kind of type of environment?
Million objects would be, I think, a fairly large enterprise. Virtualized enterprise cloud environments would certainly go to a million, but we have a deployment at a small college. I don't know how many students, about 5,000 students. 5,000 students, and we see about 20,000 interactions per second. So the number of objects, I think the physical world, you really have to have very large enterprises or providers to grow. What we find is in the virtual environment, there's really the luxury of creating objects without cost, seemingly. And people create code groups, or people create switches, VMs. They come and go, they interact, they stop interacting. So there's a tendency, probably an order of magnitude, hard to say, about a factor of 5 to 10 faster growth than you would see in a classic physical environment. So the size of the enterprise is really doesn't have to be that large for you to get a million objects. Yeah.
In terms of other data sources, I know there's a lot of V's in the room, but are you working with Zen Server or any of the other hypervisors?
Absolutely. And I think David will speak to this in the sort of the 15-minute special he has. Is we are certainly looking at other hypervisors. Different hypervisors are operating at a different level of maturity in terms of the kinds of insights they can provide. But having said that, some of them in certain markets are very, tend to dominate. So what we have to do is basically pick and choose which ones we're going to go after in the short term, and go after them and integrate it, so that we are not just a system that works in one hypervisor's world, even though it may be a dominant hypervisor. How are you doing for time today? Good. Okay. Yeah.
Scalability. Out of the box, when you set this up on the ESX host, is the defaults, can that handle a million objects? Or do you see being able to add more RAM or more CPUs to it the way you scale?
Good question. The answer is that we have a range of appliances, right? So we have what we call our standard appliance, our enterprise appliance, and then we transition to physical appliances, right? Not virtual appliances. So if you want to manage, say, 20,000 objects to 100,000 objects, that we have one physical appliance. If you want to manage 100,000 and higher, that's a different physical appliance. And this is a dedicated appliance that you'll have to use. But up to I would say 10,000 or 20,000, you can go on a virtual appliance, right? I mean, when you go to very large virtual appliances, effectively you're the only thing running on hypervisor. You're so picky that you're demanding that nothing else run. At that point, if people want, they can do that, but generally people say, well, let's just get a physical appliance.
So then the VM that runs on each ESX host is an agent. Kind of, right?
Yeah, I mean, it's an important term. I mean, I'll tell you why I'm sensitive about it, because it's a word that causes a great deal of anxiety in a lot of IT infrastructures. When they hear agent, they have certain reactions. So we talk about so what we refer to as agents are things that are inserted into the guest VMs, right? We don't think those kinds of invasive agents are really something that can scale in a uniform manner for all kinds of reasons. Some technical, some not. What we are talking about is what I would call is more of a probe, which is a VM, which is self-contained, doesn't interact with any of the other guest VMs, is just looking at the virtual switches, interacting with the local environment through prescribed APIs, and understanding what's going on and measuring things like latency. But that actually what our virtual appliance is, and that could be sitting somewhere else. Sure.
Can this work in remote office situations?
Yes. Yeah, absolutely. So where you're managing, yeah, absolutely. Yeah.
So, I mean, another obvious direction of this is for basically for billing, for chargeback, because you could do it on an extremely granular basis.
Yes.
And I'm just curious, have you seen, has there been any, customer interest in that, or are they just so excited to get, potentially just get what you've got now that they don't even think about that?
Yeah, I'll let David speak to that, but I think certainly that's an area where we expect, certain interest to come after the, we go in with the performance management agenda, right? I mean, that's what we're trying to solve. But certainly, once we are shown to be successful in that regard, I think one of the areas where there will be interest is chargeback. But I think David will give you more current insights into what he's seen.
Do you have the ability to trigger action based on?
We do. We are careful. I mean, so triggering actions, it can lead you to potentially optimization for the hypervisor, on behalf of the hypervisor, all kinds of other things. So our approach right now is to be poised for action, but not really do any action.
Well, is that something that you would develop, or would you also maybe develop an API for an orchestration engine to do that themselves?
I think that's really what we're exploring is what is a good technical as well as business separation of us triggering something on behalf of an operation environment, and how do we plug into other things that are doing it. I mean, for example, when we do things like, when VM motion occurs, they use certain attributes like CPU and memory. They may not know other things that we know in doing that. And certainly, we certainly can contribute that. But the question is, we have to work within the parameters of how those things happen. So it's an open question, but I think technically we certainly can do it in different ways. But practically, we have to be careful and pick and choose where we say we want to do this.
How far out would you estimate that capability might be for maybe yourself or a third party to do it?
I mean, I would say
A year, 2 years?
I would say it's in the year range. I would say it's 6 months to a year range.
Yeah.
It more depends on the opportunity and the pace at which somebody wants to make this happen.
It certainly is, I mean, just commenting on it, it's come up as a sort of an obvious feature request in the sense that you have a system that's looking at real time at all these interactions, and something like DRS is looking at CPU and memory and doesn't track things like interactions. And a very big deal, like on the server virtualization side, is I tend to have multi-tier applications that are in the same host. And if I'm going to make a shift, don't I want to have some of the top interactions kind of work together? So there's certainly our logic there to do it. I think what Jagan's sort of alluding to is on the partnership side, we want to do it quite gingerly with the right set of partners who want us to help take action on those things. But it's a very astute point. Is it something that you think that customers would be interested?
Yeah.
Okay.
Or building.
Okay. I'm just mindful of time. I'm seeing that we've kind of been on for about 3/4 of an hour. So what I wanted to see is if there were any sort of more kind of open door questions, that we'd want to tackle for the audience before we talk about a few things that are under the hood. Sure.
Performance management, are you also doing planning for future? Capacity planner, all kinds of things like that?
Not as of yet. I mean, again, in this broad space, right? There are products out there that tend to be optimized, today for capacity management, capacity, planning. That, that feature set is not where we are today. We certainly have report history. You can, use our reporting to do analytics.
Some, of course.
Yeah, but but we haven't kind of built our analytics, let's say, on a predictive model about capacity as of today. Just kind of one last slide for our broad audience. Just again, for those on the internet, we have two ways to take a look at our software. One is that we have a quite popular free vSphere download, which can be available on our website. If you basically go to the homepage, really, Xangati.com, it's available. As well as we have a email address if you want to get a full dashboard. Again, the difference between our free solution and a full dashboard, which is what I demoed earlier, is that our vSphere tool is focused on one host. If you want a view that kind of aggregates across your entire VI, that's where our dashboard comes into play. So for those of you who are out there, we again appreciate your time. We're going to actually, I think, I was going to ask Stephen how we do this, but I wanted to basically keep the video, but kind of stop streaming. So do we need to do anything before we transition to that?
So you'd like to turn on the stream and keep recording the video?
Correct. Okay, fantastic.
Thanks.
We have to warn you because the stream shut
Whoa.
down randomly.
Wait, have we cut the streams? Did I jump the gun? Did I give a little? Did I give a little tease?
Dangerous is always good.
As long as it's not a PlayStation 3 key on the.
Oh, it's off now. Okay. Oh, okay. Oh, thank you. Wow, in real time. Okay. Make sure. That one? That one. Okay. Hopefully you can see in the back, and after 8 hours today, you guys' eyes aren't too blurry. One of the things that I said up front about kind of our vision is, I mean, if you looked at kind of the dashboard I started out with, what we found over really the past, the course of the past year, is we had a solution that was pretty relevant for both virtual infrastructure administrators and those who were looking at VDI implementations. But what we've found is contextually, the information is incredibly broad, and when you're dealing with it, as an example, on the virtual desktop side, kind of a different background. What we see is, many of the virtualization infrastructure admins come from a sysadmin, server admin background, whereas the VDI type implementations, you really get a whole host of people, but a lot of the folks often come out of the desktop side of the house. So what we would get is, kind of a solution set that our feature set is very valuable in troubleshooting environments on the VDI side, less so perhaps on the operational side. And that really led us down a path, Jagan and I, caucused with a lot of customers, was to start kind of framing dashboards in a much more specific user-driven context. So instead of being broad, VI and VDI as an example, let's start looking at dashboards based upon kind of customer input of what would be useful for them. So let me get rid of this thing here. One of the things that we have done as well is, Jagan talked a lot about our interactional behavioral analytics. And what we try to do is, in some ways, they're a little bit buried in the general UI. We wanted to bring them front and center. So front and center, and this is what we call our VDI dashboard, that's kind of framed in a way that a virtual desktop administrator would think about things. So we're tracking the client's response time from the clients back to the hosts. We are looking at the desktops. We look at the hosts themselves. We can focus on a set of key app servers or databases that might be supporting the VDI on the back end, as well as key IT servers, connection broker, DNS, DHCP, security gateways that are critical elements. Because the interesting thing about VDI is I actually think it is an aptly termed phrase, virtual desktop infrastructure. It takes a whole host of things to basically deliver VDI successfully. inclusive of, the physical network that sits between the desktop and the data center and the client, which really could be anywhere. So the idea is that framing this in a way that the virtual desktop administrator would think about things is we bubble things up to an overall health score. And that overall health score is effectively a reflection of the profiles of each and every one of these objects. So the objects in the client sector, I think we got several clients, 3 desktops. And right now, the status of everything is quite healthy. So I have green lights in each of these areas, a health score around 100. Now, if something was out of its specific profile, the health score would effectively change. And again, things that we keep uniformly is I've got, let me focus on it down here so I can see it. I've got my DVR scroll bar, again, of the health of this infrastructure. So it's been healthy for this entire time. Now, under alerts, now if I had had a problem, and let's see if I was looking earlier today, I don't know if there was any client problems. I can take a look there. Oh, look at yesterday? OK. I'll look at yesterday, where we had some problematic things going on. I don't think we had latency issues. Client issues. OK, there you go. So yesterday, when my health index went to a low number, what I effectively have is a recording of that client. The issue at hand, I got to focus down here so I can see things, was too much use of bandwidth. So in other words, probably the VDI protocol was running heavy on the network. It was driving too much CPU, too much storage on the back end. And I've got a recording of this client throughout that whole cycle of what exactly it was doing on the network and on the virtual infrastructure at the time of the problem. So the value here, again, coming back to the dashboard, is when this number drops down to 95, 87, it's reflective of some profile changes in the different object areas. And not only is giving you, again, the real-time status of the health, it's got a recording of what happened. And obviously, it can send out alerts. In the same dashboard, again, coming back to the idea of our vCenter alerts, this dashboard, when there's a vCenter alert that might be affecting a specific desktop that's spiking on CPU, that will be reflected in this dashboard, as opposed to all the vCenter alerts that the main dashboard gets. So it's a context-specific view. I get to effectively define here what are the things that I want to track in these particular areas from anything across my overall infrastructure. And it retains a lot of the other navigational drill down. So in the monitor areas, I can effectively right-click and monitor any object. It's got a set of centralized recordings and what have you. The one piece that I do want to highlight, and I talked about this earlier, I'm just going to pull up something that we also have today that works really well in this dashboard. And this is what we call the visual trouble ticket. So the visual trouble ticket is actually something that we invented out of our kind of networking space when we were working with service providers and subscribers. When you have a problem, I think you all can appreciate this. An end user complains about something slow. It's a tail wagging the dog. The user says the network's slow or the app's slow, so you start with that and the experience. Well, what if you could actually have the user, without having an agent, effectively just go to an HTML page, press this record button, and then what I've got is a capture of effectively what that user was doing at the time on the network infrastructure. So if I go to one of our different UIs here, and I go under visual trouble tickets,